Dave Stetzer, an electrician, invented the Stetzer device, which claims to reduce symptoms of radio wave sickness. The device is a plug-in unit that filters high-frequency electromagnetic radiation, or EMR, through the use of a capacitor. Stetzer initially focused on stray voltage issues before expanding into the field of electromagnetic sensitivity. The Stetzer device is a small black box that plugs into a standard electrical outlet. It contains a capacitor designed to absorb and dissipate high-frequency EMR. Stetzer claims that the device can reduce symptoms associated with radio wave sickness such as headaches, fatigue, skin irritation, and sleep disturbances. However, there is limited scientific evidence to support the efficacy of the Stetzer device. Some studies have shown a reduction in symptoms, while others have found no effect. The claims made by Stetzer have been met with skepticism by some in the scientific community. Critics argue that there is a lack of credible evidence to support the device's effectiveness. The Stetzer device is available for purchase through Stetzer Electric's website. Let's delve into the technical aspects of the Stetzer device and the claims surrounding its ability to mitigate the effects of electromagnetic radiation. We'll examine the role of the capacitor in filtering high-frequency EMR and explore the potential mechanisms by which such a device might influence the human body. It's important to approach claims about reducing radio wave sickness with a critical eye, considering the available scientific evidence and potential confounding factors. Let's begin by understanding the nature of electromagnetic radiation. Electromagnetic radiation is a form of energy that propagates through space as electromagnetic waves. These waves are characterized by their frequency and wavelength. The electromagnetic spectrum encompasses a wide range of frequencies, from low-frequency radio waves to high-frequency gamma rays. Radio waves, microwaves, infrared radiation, visible light, ultraviolet radiation, X-rays, and gamma rays are all forms of electromagnetic radiation, differing in their frequency and wavelength. The Stetzer device specifically targets high-frequency electromagnetic radiation, which is often associated with electronic devices and wireless communication technologies. The device utilizes a capacitor to filter these high-frequency components. A capacitor is an electronic component that stores electrical energy in an electric field. It consists of two conductive plates separated by an insulating material called a dielectric. When a voltage is applied across the plates, an electric field forms in the dielectric, causing an accumulation of electric charge in the plates. The amount of charge that a capacitor can store is proportional to its capacitance, which is measured in farads. In the Stetzer device, the capacitor is connected in parallel with the electrical circuit. This configuration allows the capacitor to act as a filter, shunting high-frequency signals to ground. High-frequency signals tend to take the path of least impedance. Since a capacitor's impedance decreases with increasing frequency, high-frequency signals are more likely to flow through the capacitor rather than through the rest of the circuit. This filtering action reduces the amplitude of high-frequency components in the electrical environment. The proponents of the Stetzer device claim that reducing high-frequency electromagnetic radiation can alleviate symptoms associated with radio wave sickness. These symptoms are often attributed to electromagnetic hypersensitivity, a condition characterized by adverse health effects in response to exposure to electromagnetic fields. However, the existence of electromagnetic hypersensitivity as a distinct medical condition is a subject of ongoing debate. Many studies have failed to find a consistent link between exposure to electromagnetic fields and the reported symptoms. Nevertheless, some individuals report experiencing a range of symptoms, including headaches, fatigue, skin irritation, sleep disturbances, and cognitive difficulties which they attribute to electromagnetic exposure. The Stetzer device is marketed as a solution for reducing these symptoms by filtering out high-frequency electromagnetic radiation. It's important to note that the effectiveness of the Stetzer device has not been conclusively established by scientific research. While some studies have suggested a potential reduction in symptoms among users of the device, these studies often have limitations, such as small sample sizes, lack of blinding, and potential for placebo effects. Placebo effects occur when a person experiences a benefit from a treatment simply because they believe it will be effective, even if the treatment itself has no inherent therapeutic value. In the case of the Stetzer device, it's possible that some users may experience a reduction in symptoms due to the placebo effect, rather than the actual filtering of electromagnetic radiation. Critics of the Stetzer device argue that there is a lack of credible evidence to support its effectiveness. They point out that the electromagnetic fields generated by typical household appliances and wireless devices are generally well below the safety limits established by regulatory agencies. These safety limits are based on scientific research that has assessed the potential health effects of electromagnetic exposure. Critics also argue that the Stetzer device may not be effective in reducing exposure to electromagnetic radiation from external sources, such as cell phone towers or radio transmitters. The device is designed to filter electromagnetic radiation within the electrical circuit to which it is connected, but it does not block external electromagnetic fields. Furthermore, the Stetzer device may not address other potential sources of electromagnetic exposure, such as magnetic fields generated by electrical wiring and appliances. Magnetic fields are distinct from electric fields and are not affected by the capacitor filtering mechanism employed by the Stetzer device. Despite the controversy surrounding its effectiveness, the Stetzer device remains available for purchase. Consumers who are considering purchasing the device should carefully evaluate the available evidence and consult with healthcare professionals to determine if it is appropriate for their individual circumstances. It's also important to consider other potential interventions for managing symptoms associated with electromagnetic hypersensitivity, such as reducing exposure to electronic devices, improving sleep hygiene, and addressing underlying medical conditions. In addition to the technical aspects of the Stetzer device, it's important to consider the broader context of electromagnetic radiation and its potential health effects. Electromagnetic radiation is a ubiquitous part of the modern environment, and exposure to electromagnetic fields is unavoidable. However, the vast majority of scientific evidence suggests that exposure to typical levels of electromagnetic radiation does not pose a significant health risk. Regulatory agencies around the world have established safety limits for electromagnetic exposure to protect the public from potential harm. These safety limits are based on extensive research that has assessed the potential health effects of electromagnetic fields at various frequencies and intensities. The safety limits are designed to provide a wide margin of safety to ensure that exposure levels remain well below those that could potentially cause adverse health effects. It's also important to distinguish between ionizing and non-ionizing electromagnetic radiation. Ionizing radiation, such as X-rays and gamma rays, has enough energy to remove electrons from atoms, which can damage DNA and increase the risk of cancer. Non-ionizing radiation, such as radio waves and microwaves, does not have enough energy to ionize atoms. While non-ionizing radiation can cause heating effects at high intensities, it is not considered to be a significant cancer risk at typical exposure levels. The Stetzer device is designed to filter non-ionizing electromagnetic radiation, specifically high-frequency components, in the electrical environment. It does not address exposure to ionizing radiation or magnetic fields. In conclusion, the Stetzer device is a plug-in unit that claims to reduce symptoms of radio wave sickness by filtering high-frequency electromagnetic radiation. The device utilizes a capacitor to shunt high-frequency signals to ground, reducing their amplitude in the electrical environment. While some studies have suggested a potential reduction in symptoms among users of the device, the evidence is limited and the claims have been met with skepticism by some in the scientific community. Consumers who are considering purchasing the Stetzer device should carefully evaluate the available evidence and consult with healthcare professionals. It's also important to consider other potential interventions for managing symptoms associated with electromagnetic hypersensitivity and to be aware of the broader context of electromagnetic radiation and its potential health effects. Remember that electromagnetic radiation is a complex phenomenon, and its potential effects on human health are still being studied. It's important to rely on credible scientific evidence and to be wary of unsubstantiated claims. When evaluating claims about reducing radio wave sickness, consider the following factors. Firstly, the strength of the scientific evidence supporting the claim. Look for studies that have been published in peer-reviewed journals and that have used rigorous research methods. Secondly, the credibility of the source making the claim. Be wary of claims made by individuals or companies that have a financial interest in promoting a particular product or service. Thirdly, the potential for placebo effects. Be aware that some people may experience a reduction in symptoms simply because they believe that a treatment will be effective. Fourthly, the potential for confounding factors. Be aware that other factors, such as stress, diet, and underlying medical conditions, can also contribute to symptoms associated with electromagnetic hypersensitivity. Fifthly, the safety of the intervention being promoted. Be sure that the intervention is safe and does not pose any significant health risks. Ultimately, the decision of whether or not to use the Stetzer device or any other intervention for reducing radio wave sickness is a personal one. It's important to weigh the potential benefits and risks and to make an informed decision based on your own individual circumstances. If you are experiencing symptoms that you believe may be related to electromagnetic exposure, it's important to consult with a healthcare professional. They can help you determine the underlying cause of your symptoms and recommend appropriate treatment options. They can also provide guidance on reducing your exposure to electromagnetic fields and managing any associated symptoms. The key to navigating the complex and often confusing information surrounding electromagnetic radiation and its potential health effects is to remain informed, critical, and proactive in your own health care.